You almost snuck that in there. You realize that, right? I don't. Yeah. Yeah, I don't know if that could have been any closer. Thank you. And welcome back to this episode of the At 10 Gallons Concrete Podcast. We have with us Dr. Jon. Jon, well, he was there. I think he spit his water out. He's off camera. Oh, we got him back. Okay, red-faced, but here nonetheless. Thank you for joining us, sir.
Great to be back. I hope we have a good internet connection.
You are coming through loud and clear for the folks' little inside baseball. We tried to record this a week ago or so, and the internets were not cooperating, and we had to reschedule. But we're here now, and it's going to be a beautiful conversation with beautiful people. I'm
a little nervous because Joey is starting to pixelate.
No, don't worry about him. The great news, more inside baseball for everybody. The studio that we're working inside of is going to record everything, all your audio, all your videos, full HD, native to your connection. So as long as you have a strong connection, you're going to come in great. Don't worry about how it's connecting to Joey.
Wow.
Great news, right?
Right. You should promote the Riverside product. That was really good.
Riverside.fm. Check it out for all your podcasting needs.
Yes, the world needs more podcasts.
Yeah, the world needs more podcasts. That's going to cost them. That's a $500 ad read. We're going to need to send the invoice. But enough about that. We've got Dr. Jon. So the conversation today, he's been on here a few times, but the conversation today, we're going to dive into concrete repair. It's our contention here on the podcast that the ability to see a concrete failure and accurately diagnose what happened to that concrete to make it fail is a lost art. It's a rare skill. Those guys are few and far between, and it is our opinion that we have one of those people on the podcast here with Mr. Jon Belkowitz. So how did we decide to center this conversation around this? Well, that's Jon's fault because he's out there advertising this new product called Ediston. So we are going to touch on that today, but my concern is, like, how do you know when to do something? How do you know how something failed? And you know what? I know Jon's got thoughts. So, brother, when we're talking concrete repair, where do you start?
So, the great thing about concrete is you start with the letter C. I mean, that's why the good Lord above started concrete with the letter C, because it cracks. And from the very beginning, we cannot get past the fact that concrete will crack. Nobody in the world knows anything. And when I say nobody, I'm using Pareto's law of 80% of the people out there. I'm not talking about the president company excluded, which is the 20% of us who make the 80% of the concrete world happen. But 80% of the people out there, they know nothing about concrete except for it's gray and it's cracks. Outside of that, they mistake it for cement. So when we talk about, can I share some slides? Am I allowed to do that?
Yep, please. Mm-hmm. And for those that are on audio only, we will have clips available. Please follow them on our social medias, especially LinkedIn. So if Jon actually says something interesting here, which I expect he will, and you want to see what it is he's referencing, please follow along on our LinkedIn pages. That's Add 10 Gallons Concrete Podcast on LinkedIn. And you can also find a lot of those shares through Joey and I's personal page. So, Dr. Jon, take it away.
What I'd like to do when I talk about concrete is I try to define the different types of concrete cracks. Now, from there, I don't like to talk about Eddystone because, quite frankly, or Susan, I don't care if you use Eddystone. There is enough damaged concrete, somewhere around 42 trillion of structurally deficient concrete. I'm sorry, 4.2 trillion, my bad. The decimal point really matters but there's $4.2 trillion worth of structurally deficient concrete. Like, even if the entire market wanted to use Eddystone, there wouldn't be enough product to go around. Okay? So the way I want to talk about it is generalities, and the start is concrete is going to crack. We talked about that. Wrong presentation. Let me go back. Concrete.
No, while you're pulling up that presentation, it's interesting to talk about concrete cracking. One of the very first lessons Joey and I learned back in school is concrete will crack. Your goal was to tell it where to crack, and that was how we got introduced to joint spacing.
And you know, the reality that they didn't tell you is you can't tell it to crack. Concrete is like, I don't know, a toddler. You can't tell him when to eat. You can't tell him when to... Look at Joey. Joey is just nodding his head.
I'm like feeling all this right now. Mm-hmm.
Are you guys?
I think he wants tacos. I don't know.
Are we going through some sleep regression?
Oh, all the time.
All the time.
Baseline is, yeah.
The girls are sleeping in our bedroom right now. One on the couch, one on the floor, and then one in the bed. And that one is the smallest, and somehow she just, attacks. Anyway, concrete's going to crack whenever, however it wants to. And there is little that you can do to control it. You can cure it longer, blah, 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 blah. But once it starts going through the throes of cracking, whether it's from chemical use or chemical physical attack, or just from use, so do as much as you can. Can we all agree here that ultra high performance, even you remember the Extensia stuff? You guys remember?
You're going into the brand names now. We're going to talk about your paper of the month later, and I was curious if it had any of the brand names in it. I was like, is it going to start talking about Agilia?
Extensia.
Extensia.
It was never supposed to crack, It cracked everywhere, especially if you're in Georgia. The reality is concrete cracks. Now, one argument that people have is that no concrete mix is created the same. No two concrete mixes are created the same. Would you guys agree to that?
Wholeheartedly.
Yeah, I would. Natural materials, yeah. Absolutely.
Even two residential mixes. But when we look at concrete cracks, there's a difference between the two phrases, by the way. When we look at the differences between concrete cracks, we could put them into three categories, right? And I really like to simplify it, but if you guys disagree, I'm always a student. I'm always trying to learn. So I'm ready to hear the pushback. But you have a concrete crack that's going from surface to subsurface. The diameter is bigger at the surface than it is subsurface into the crack. Whether the crack is dry or it has poor water solution, it's not just water and it's not just open space. There's normally some type of sulfate, alkali, chloride, calcium hydroxide, other type of ions or species that we would normally find in concrete or the stuff that we use on concrete. So far, am I doing all right?
Mm-hmm.
Yep. Yeah, we're following you along. I think there could even be another bullet point here, actually, when I'm looking at this slide. Between 2 and 3.
That's why we record this stuff. I'm writing this down. Go ahead.
Perhaps you're going to touch on it later. So sorry if I'm getting ahead of you. I look at this, and the next thing I expect to see is you're gonna tell me that poor solution could also freeze. When it freezes, it expands, and you're going to accelerate your third bullet point that you have here.
Let me say it differently. Say yes, but that water is in a bulk state, meaning it can freeze, it can thaw, it can evaporate. It's not just volume change from freezing, but if we're in Texas, it's volume change from wetting and drying cycles. If we're in a marine structure, it's wetting and drying or salt cycles.
Yeah.
But it's the same thing that you said. I just want to put that bulk so it's a more general statement. And by the way, my entire desk is white tiles so I can use pencils to write notes everywhere.
That's slick. It's a giant, it turned it into a giant sticky note, giant whiteboard.
Right? And I always lose sticky notes. I don't lose these tiles. They're attached to a 200-pound desk. Anyway.
No, hold on. No, now it makes sense. So for those who can see the video, John's wearing long sleeve shirts. It's actually warm outside finally. But you see the marker? Did you see the marker on his sleeve? He's wearing the long sleeve shirts. So he doesn't get that Sharpie, that orange marker all over his forearms.
I actually wear because my skin reacts to cement and it blisters, but that works too. Yeah, I do a whole video on it.
What? You're like the cement mixing guy. And
if I get cement on my arms, it will and it'll stay that way for weeks, sometimes months.
Wow. Well, hey, for all those listening though, proper PPE states that if you're working with concrete and cement, you should be wearing long sleeves, gloves, and respiratory gear.
We buy all these shirts for our employees, and we do not care how many they go through. Yeah, I used to put my hands in concrete, never used gloves before, and then one day it all changed. Go check out the video for more information. Okay, so the third type of crack is when the concrete has exhibited, and again, this doesn't mean that it hasn't already gone through the throes of failure, but now it's exhibiting those throes of failure. What I mean by that is the gels that are white and yellow, they're gels that are, not white and yellow, that are red. Like once we see that, the map cracking, the Isle of Man cracking, the pop outs, it's past failure point. Now we need to start talking about hospice, right? Or major repairs that contain the failure and contain an environmental issue. All of this, does it make sense?
Yeah, we're with you.
Okay. What we have after this is what can we do to rejuvenate, rehabilitate, or even repair the concrete? And there's two types of technologies that we can use: healing and self-healing. Now, self-healing assumes that whatever is rejuvenating the concrete, healing it, was already in the concrete. We didn't have to add it after the fact. Whether that's what's that stuff from Delft University, the biological capsules and they create their own jelly and the jelly hardens. You know what I'm talking about?
No, but now I feel silly that I don't know.
Right. There's also, no, I don't think you should feel silly, but check it out. It's called TU Delft. And Joey knows the name. You met these guys, didn't you? Don't you remember when you and I were sitting together in the ACI meeting and you're like, Joey Bell, 10 more gallons. And I was like, that's I didn't know we were allowed to say, podcasts. Oh, sorry, beep. That meeting, that dude was in there who was selling that biological technology that you mix in the concrete and when it cracks, it heals. Mm-hmm. There's also a polymer version by a company called Cortec that goes on the steel, and that stuff is wicked awesome. But again, all of this is put in the concrete before failure. Right? Healing technology assumes that the concrete has already failed, and now you need to either inject or topically apply the technology similar to an antibiotic or some type of intravenous pharmaceutical. Does that make sense? Mm-hmm. Okay. The technology that I talk about is a topical technology that is applied to the concrete after failure. Now, that failure can either be naturally occurring because of physical or chemical attack, use, or it could be manufactured, i.e. grooving the concrete or de-icing, salted, or braiding it. Does all that make sense?
Oh, yeah.
Okay. That's my cue for, do you guys have any questions? Sorry.
Well, I think we got a bunch of questions, but my concern, Dr. John, is that you're going to answer these questions as we get to the next slides.
If you ask them, you might ask them a different way than I'm going to explain them. But okay, so the type of technology, again, this is what our technology is, but there are other companies like this all over the flipping world. It's a topically applied colloidal silica that uses the concrete in a way that the body uses a moisturizer. As a matter of fact, the first name of the company wasn't what it is now. I called it Eau de Soleil. Nobody liked that name, but it meant, Joey, don't laugh that much. That's not nice.
Sounded like you're throwing up, to be honest with you.
What's that?
Sounded like you were throwing up.
Eau de Soleil. It's called Water of Life. It was like a moisturizer. And we're using the vascular cracked nature of the concrete to transport the technology to the most important point, which I'll show you in a second. But it is a colloidal silica based that combines with the concrete that's in a saturated surface dry condition, and it diffuses, which is a much better word than penetrates, into the concrete. But I like saying penetrate because that sounds funny. But more importantly, it diffuses into the concrete. Cool. What questions?
Well, I think it's interesting that you're this deep into this subject, and you always seem to have a way to take something that is super niche that could be super broad and just become like this, one of the most well-versed guys at it. We've got other friends in this business that they're well-versed in repair techniques too. Maybe they typically deal with, pavements. So they're looking at partial depth or full depth replacement. We know folks that are doing tunnels and pipes even where they got hydrogen sulfide attack. And so the best thing for them is, or that they think anyway, is to just apply a new layer of concrete on top of it. So they're doing, spray on bond, just bonding new concrete to old concrete to give it a new protective shell. So there's different repair methods, and I think it might be good if we pause on the discussion for just a moment and sort of explain, like, how did you get to playing with a topical colloidal silica product as a healer for concrete? What made you decide to go in that direction with some of the other, maybe we can talk about some of the other repair methods that are out there, and what made you say, you know what, I think this is the future. This is where we need to be looking.
It's the dumbest freaking story in the world. I love my stories. No, I've got some good ones. This is the dumbest one. We were in the shop. I was playing with structural lightweight expanded shale from what are they called in Boulder? Trinity.
Well, in our opinion, you're only buying this stuff from our friends at Staylight. If they want to give me a commission check on that, that's fine. I won't.
They might
turn
have
it down.
bought them, so I think that is the case, that they bought the facility I'm talking about. So, I've been playing with colloidal silica since I had a full head of hair. Seriously, back in 2004, right as I got out of the military and I was getting into concrete research, it was the first thing that I picked up. And then I met Brian Greene and I fell in love with him. I mean, not in a weird way. It was weird. It was totally weird. But this is years later, couldn't sleep. Jessany was a very colicky baby. And the shop was in our, I'm not embarrassed to say this, but we just moved from my mom and dad's. We had this rental house in Broomfield. We then got Mama B and Mr. B's house. We just didn't have the money to build our own shop, so we're in the garage. And it's like 3 o'clock in the morning, and I couldn't sleep. So I got some of this Staylight expanded shell structural fines, 10% off if you use this code. And I mixed it up with some colloidal silica. And then Whitney called me and she's like, Jess woke up. Can you get her a bottle? I was like, yeah, that's no problem. So I ran over, you had to get the bottle, and you can't microwave it because it ruins the milk, and it still has to be warm. And so I ran upstairs. I talked to Whitney for a little bit. Jessany calmed down. I went back. I was like, I got a mix I got to go do. So I go down to the shop, and I had only mixed the expanded shell with the blah, 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 with the colloidal silica. That's it. No cement, no water, and set up like a bat out of hell. Like, I had to get a new mixing bowl. It had set up, and it had formed.
For everybody on audio, Dr. Jon just got really excited by a memory. and he just left the screen to go fetch only God knows what. Joey, what are you thinking about this guy?
I don't ever know what to think. I just let him roll with it.
That's why we love Dr. John. And for those of you who haven't caught his other episodes, Dr. Belkowitz has been on the show multiple times. Love having him here. Now he has just returned with a plastic bowl, and please explain to the audience what you're holding there.
It's a restaurant Tupperware.
Yeah, I was gonna say like to go takeout bowl, but I wasn't.
I love takeout bowls in the lab. Takeout bowls in the lab are the best. I mean, don't use them after you get takeout food because that'll mess up your mix. But this is concrete sand, and this is mixed it up with the sister product to the Eddystone. It's called Geostone, but it works off the same concept. So we either mixed it up or we allowed it to saturate through the surface from the top surface into it. And it basically did the same thing. I pulled the paddle out, and the next thing you know, I got 800 PSI of strength. Right?
Wow.
Huh.
And I was like, I know I've got something, I just don't know what it is. And what we discovered was, and I know you said don't use your presentation.
No, I didn't say you can't use your presentation. Everybody knows on here this is not an infomercial. We're talking about cool stuff. And you just happen to have something that's really cool. And it's about a subject that people, although we're all concrete fans, we're not all repair experts. It is so hard. How many of us out there have the NRMCA level 4 certification? Me and like 100 other people, and I'm not a repair expert, and I even took the dang course. So the ability to see broken concrete, diagnose why it's broken, to even run the test to figure out, like, this is why I think it. What test do I run? Do I even think might be the reason this concrete is broken, and then determine it? There ain't a whole lot of them out there, man. So
we can go into that here in a second too. But for those of you who want to read a paper about this, there's a guy named Frank Crundwell, and here it is. Frank Crundwell. He talks on the mechanism of the dissolution of quartz and silica in aqueous solutions, but it goes into what we're about to talk about too, this gelation process. So I understand there's not that many, and we'll go into that, but I wanted to talk about what's going on here. Is that okay?
No, please.
Okay. So what we're dealing with here, whether we're playing with the concrete sand or we're dealing with the cement, is there's a certain amount of salts and water in our pore structure, whether that's cracks, whether that's voids, or if it's a collection of sand with a bunch of saturation to it. What we're going to do is spray that colloidal silica over the surface. Now, why it's important that it's colloidal silica, and let's say something like a silicate, or something that's being called a silica and it's really a silicate, is that those technologies, although were good at the time, they will react at the surface and you can't get them to diffuse deeper than the surface because, in fact, they are not discrete nanoparticles. They're even smaller than that. They're solute in solution. And those were great back in the 70s and 80s, but so were typewriters. We don't use typewriters anymore for a very good reason. What?
That's great. That's a great analogy, and I've got more questions. So please continue, because I don't want to interrupt. I feel like we got you on here to talk about this. So I need to be quiet. I want to hear every bit of this, please.
So what we do is the reason why. So where we went from combining the structural finds with colloidal silica was identifying that, like authors like Frank Crundwell and others, that it's a destabilization of the colloidal silica suspension, which is caused by a change in electronegative potential from the salts. So the nanosilica swims in a very stable solution, which is based on a pH. You know, anytime I talk about colloidal silica, I say can't go above a pH of 10.7. Well, what the happens? Excuse my language. What happens when it goes to a pH above 10.7? or better yet, a pH that it wasn't designed for, I think is a more general way of stating it. The answer is it destabilizes. Now, if you choose the right nanosilica size distribution and coating, to a certain degree, you can control that dispersion. It can give you a great for instance. If we make the nanosilica particle so flipping small, it's 1 nanometer, it's going to react immediately. If we make it even smaller than that, it's going to react even faster. Now, if we go the opposite direction and we get a particle size distribution somewhere between 45 and 47 nanometers, something that's a little bit closer to what we would see with the silica fume on the finer end, it's going to take a lot longer to react. And then if we coat that particle, not the whole thing, but a portion of it, again, and we stabilize that pozzolanic reaction that often takes off very quickly, it'll diffuse or penetrate even deeper. Now, what happens after that? It's not just a destabilization of the nanosilica suspension, although it is, but now we're getting this trapping of the alkalis in the water that's in our pore water solution. And that's called a hydrogel process. Now, you guys are very, very familiar with hydrogels and you don't even know it. ASR, it's a hydrogel. Calcium silicate hydrate, it's a hydrogel. Even the pacification layer over steel is a hydrogel. Even Eau de Soleil, terrible name. But the hydrogel that we create is rich in calcium hydroxide and reactive silica. And when you put those two together in the concrete industry, it starts with a P and it rhymes with schmozzolonic reaction.
Great.
So at first we developed these hydrogels that bridged cracks, and then they eventually heal the cracks by converting into more of that backbone of concrete strength, that calcium silicate hydrate.
How deep does it penetrate concrete? Because you were looking at your little show and tell earlier with the food dish, which was very interesting. So I hope I hope that clip survives on the internet. It was very interesting, and I was curious how deep, because it went very deep in that takeout container. The takeout container was what, at least 4 inches deep, 5 inches deep, and it went all the way through that.
Yeah, so, nope, it's this one. Yeah, this one, it penetrates. So, but this is for soil. Soil has a much, much higher permeability than concrete.
That's why I was asking, because I'm curious how far it goes into concrete.
So I want to be careful about saying that, because there are some companies that will tell you that you can use this type of technology on brand new concrete. And I want to be the first, if not the only one, to not oversell this stuff. If you use this stuff on brand new concrete, you're throwing money away. Like, it is a waste of money. Now, if you intentionally open up your concrete, like grooving it, or these guys I don't think I need to be worried about making fun of them. At the Colorado Springs airport. No. There's no way I'm going to find the picture. But if you ever go to the Colorado Springs airport, look at the concrete pavement for the parking lot. For every stripe that they did, they ground with a 14-inch grinder the entire length of the line, like 8 inches on either side. And it is awesome. Like, the paint is never coming up, but dude, how much money did you spend? Like, they really hurt the grinder. This wasn't and they did it the entire, and it was like a single guy doing it. That's who you need to interview, is the guy who sold the engineer. Like, this is what we're going to do.
They must have run some kind of cost benefit analysis and be like, the paint will never come up. You never have to repaint it for 20 years, 30 years. I mean, how much paint could that actually be? It can't be.
Airport had to get rid of some money is what happened.
It was a government contract.
Yeah.
Thank you for saying that, Joey. You guys once interviewed Colin Lobo. You remember that?
Yeah.
How do you forget such a monumental guest?
Do you remember the best part?
Well, I know your favorite part, but you should share it because your enthusiasm comes out. So
No, it wasn't my enthusiasm, Paul. It was yours. And Colin's like, well, Paul, I really don't know. We can't see that far ahead. And you're like, come on, Colin. That's why we do these shows.
Speculating's half the fun. That's right. Yes, sir. Yes, sir. He's too much of a professional to do all that.
I know. He doesn't want to let me take the what's it called? The exams.
Why not?
I'll pull up the message. He goes, you know too much. But I said, I can't wait to take it. Like, I'm really looking forward to taking it. He's like, no, you're not allowed to take it.
Yeah, if people didn't hear that interview, I'll say it again. But he knew us. He knew Joey and I from our time at MTSU at school. So he knew who we were. And I remember being in the level 2 and level 3 class, and he just picked on me the whole time. Because nobody wants to raise their hand.
Right.
But he knew me and would make me answer every question. And then when I did level 4, I was so thankful that he wasn't teaching because I knew that I could sit there in peace and let other people get called on for a turn. You
need to take that level 4 over and take it with him.
I actually forget who taught it. It was a professor from UT Austin. Forget who it was.
Okay, that sucks that you forgot Kevin Folliard.
I don't remember. You can name. Dude, you could have made up any name. You could have named like baseball players from the 1980s. Robin Yount. You don't remember Greg
Darryl Strawberry?
Darryl Strawberry was your David Justice? How do you forget? The greatest professor ever, David Justice.
Kevin Folliard is one of those greatest professors ever. So, but okay, let's go back to your question. How do you know how much it penetrates or how deep it penetrates?
Yeah, I think it really matters because I'm thinking constantly of there's other repair techniques that could be done. We don't just have to spray magic juice on stuff, but the magic juice seems pretty freaking awesome. Right. So how deep does it go? Because that might inform us about we can use magic juice instead of.
It goes as deep, and this is going to sound so philosophical, as the concrete needs. There's a little bit of artistic hand-waving, but remember I said that this doesn't penetrate as much as diffuse into the concrete. So that requires two things, cracks and water. Now remember, the particles that we're dealing with are on the nano scale. And molecules of water are just below a nanometer. So we're all within the same realm, and they're going to eventually combine. It's called dynamic equilibrium. Now, I know I sounded a little philosophical when I said it depends on how much the concrete needs, but I want to take a moment, and I don't think anybody really does this. We all talk about concrete cracks, but nobody has ever defined a concrete crack. Can I do that?
Yeah, please, take it away.
It's not just about concrete cracking. It's about concrete crack propagation. Because if a concrete cracks and it never cracks again, who cares? Right? We never care about it. But when a concrete cracks and then it continues to crack, and then there's salts that migrate with some moisture, the concrete repair sometimes, and I think it can be argued oftentimes, will debond, delaminate, and then you got to redo the repair. That's the worst part of a concrete repair. Coming back to it. Right? It's like being a ready mix producer. What's the worst part about being a ready mix producer?
Oh, wait, you just want one?
Yes, I just want one.
Oh, man. The worst thing. Tearing out a job, that'd probably be the worst thing you'd ever.
No, because then it goes on other people. No, it's a return truck. Forget a rejected load, but a return truck is like getting stood up on a date. It's like getting a dish turned back from a table. It is nobody's fault but your own. Tearing out concrete, it was the contractor. It was the guy who did the cylinders and left them on the slab. It was the rain. It was Hashem who messed, because the only thing a ready-mix provider is accountable for is from what? To the gate? Well, when their concrete gets returned through the gate, they lose something called a Christmas contract. They lose their margins. Because not only did they waste the time on that truck, now they have to throw out the concrete, now they have to bring concrete back to the customer. And they've lost some face with the customer too. So, going back to, man, do we tangent? Going back to a concrete crack, I hear people talk about it, but they don't often understand what they mean when they talk about concrete cracks. So I just want to take a second to define it and talk about the mechanics, if that's okay.
Yep, please.
How did we get into the whole rejected truck?
What is the worst thing about being a ready-mix producer? Be having your concrete returned.
Oh, slap in the face. Gosh, that's true. So true. I would say that again. So when we talk about a concrete crack, it's the concrete that is already cracked. We call that A. It's the large diameter, smaller diameter, smaller diameter, and it's the plastic region that has already gone through some micro and nano cracking so that it doesn't have its elastic property to it. And if I don't know if you guys remember back from school, we have this Young's modulus where our concrete is in an elastic region, meaning that the atomic atoms can dislocate and they can go back to their original position. What we've said here is that the crack has not yet propagated, that we have lost material, but the material, the hydrated cement matrix and the concrete composite, has already lost some of its elastic properties. And that section is our crack plastic zone. Any questions? Okay. Now, crack propagation occurs when the applied stress is equal to the capacity of the localized material. Not greater than, but equal to. Now, the reason why is, remember, applied stress is not going to be equal to the stress at the singularity point or where the crack tip is. Because of geometry, our applied load transfers into something that's 100 times to 1,000 times greater than the applied stress. We have a distributed load up top, and now we have a point load, which is in the microns. And what is it? Force equals, or stress equals P over A. Since our area is in the denominator, as my area gets bigger, my stress gets smaller. As my area gets smaller, my stress explodes and it overcomes the shear and tensile capacity of my hydrated cement matrix and our concrete cracks. Does that all make sense?
I did not know we were going to get a lesson on rational expressions, but here we are today, learning from Dr. Jon. I mean, we could graph this out if we need to, but yeah, it makes sense.
I don't want to graph this out. What I do want to show is what we're doing with these different types of technology. And this goes back to your question, how deep does it penetrate? It penetrates as deep as the concrete needs to. What we need to do is not just change up the material science, change this from an open structure that is not going to give any bearing strength, any load capacity to it, to now we have, it goes from an open crack to something that's filled with a bridging hydrogel and it gives the concrete crack some strength. Now what we're doing is we're changing up the geometry. Instead of going to a point load at the crack tip, we go to a load distribution. So it's not just about what the colloidal silica or the nanosilica does to the concrete. And as you asked how much it penetrates, it matters what that gel is doing through what it has penetrated. Because what we show here is these different hydrogels. First it's just a bridging gel. Then it becomes a healing gel when it becomes a darker blue. And then, or a blue. And then when it becomes its darkest blue hue, we're saying it turns back into that calcium silicate hydrate, which is ultimately what we want. Now we have a strength-bearing structure. But even if it didn't do that, and even if it didn't penetrate that deep into the crack, as long as we're starting to get into the subsurface and not on the surface, we're changing the geometry of the crack, and we're changing the load distribution. I know that's a lot.
Yeah, I think you said the key phrase there is changing the load distribution. That's what makes this make sense. As long as you can reach that. I don't know if did you call it the singularity? And I think you have it. It's about as close as you can get to the singularity, to where whatever crystal's being formed there is going to completely fill that void. And now, instead of having that extreme pressure on a single point, you've got pressure over a larger distributed area, and it greatly reduces the amount of force going in. But I'm telling you, if you're watching this today and you're looking at this, you had no idea that you were going to be looking at this is algebra 2 level stuff. I mean, this is
it's calculus.
Okay. You're really advanced here on the show. I didn't realize we always think we're gonna get smarter when we have our guests on, but this is next level, John.
There is a great book by Michael Ashby and David Jones called Engineering Materials 1. It's chapter 14 on the mechanisms of fast fracture. And what you talked about right there, the crystallinity, I mean, concrete, when it gets strong enough, it acts like a ceramic material. And because of that, it goes through fast fracture. Now, there is a type of failure mechanism that sounds dirty, and you can bleep it out, but it is a mechanics of material expression. It's called cleavage, right? It's when the fracture happens so fast that you get interatomic layers peeling apart, and then you have bonds start breaking. The bonds are cleaving, and it goes through what we call brittle failure. Chapter 14, section 3, page 185. If you really want to be smart, don't listen to me. Read this book. This book changed my flipping life when it came to mechanics of material and what we're talking about here. By arresting and changing up that load distribution, we're doing something called crack blunting. And when you spoke to Megaslab, I think.
Yeah, Jason Adams. Yep.
Jason Adams, thank you. Awesome dude. He was talking about how they were going through such distances between saw cut joints. And part of that is what he's doing with his combination of technologies. And I think he did it with Tyler, which is, in essence, crack blunting. He's arresting those cracks and slowing them down before they become fast fracture.
Yeah. And for those who aren't familiar with Megaslab and Jason Adams, we did have him on the show before. He does have an interesting technology. It's unbelievably strong concrete that, originally he was trying to make it crack free. And then he decided that he's actually got these special joints that he can put in. That way it doesn't have to be jointless pavements, but super, super strong, unbelievably durable stuff, like crazy, crazy durable stuff.
What Jason does that nobody else, and it wasn't just him, it was Sylvester and his other guys on the team. It's not just one technology. Like, they do more than one technology in the concrete, and in doing so, they do a combination of the hydrated cement matrix and the granular skeleton to cause that crack blunting. It's awesome.
Yeah, I remember being in his warehouse, and just a few years ago, and was walking through, and the operation was clean, it was simple, and he said, if we've got authorized installers, then this should work like a charm. And at the time, he only had I think one guy doing it at the time, and then they had just a couple major accounts. And now look at him. I mean, it's just
huge.
It's really impressive. So.
Yeah. Agreed.
All right, so we see the calculus, we see the cute little diagrams about the fun hairspray that's going on the concrete. And you know I'm teasing you because we love you. So those are all jokes, folks. Don't think don't think he's about to drive over from New Jersey over here to Philly and whoop my butt. He knows we're playing. But in all seriousness, the reason why this looked cool to us and we wanted to talk about concrete repair was because we saw the before and after shots of this tunnel out in the field.
Oh yeah.
And it doesn't look real. It doesn't even look.
Yeah.
It doesn't look real. It looks like you made it up. Like it looks like you doctored it on like a PDF. So this is your chance to tell the world that you did not Photoshop that picture.
I didn't Photoshop the picture. I have tried to Photoshop pictures, and Patchouli can tell you all about it. She and it's on Instagram. And what did she say, John? That type of purple doesn't exist in nature. Everybody can tell you're photoshopping. So I have tried. I am not good. But hey, you can go to this tunnel and see what it looks like. And it's not magic. It's just the technology, and it's what it's doing. And this did not mean it fixed the problem long term. Do you mind if I tell the story behind this?
Yeah. Go ahead. I think it helped. I think it helped the folks to know what the heck we're talking about here.
Yeah, and we're moving out to Auburn here in the next 3 weeks, so we're officially Hoosiers at this point. We're taxpayers, so I care what happens to Indiana infrastructure. And this was a concrete structure built by R.L. McCoy back in 2002 for the Cruz family to be used to shuttle back and forth rare Fords underneath the highway. And we're talking multi-million-dollar Fords. Where that front-end loader is, to the right of it is a Ford museum where they have 1932 to 1936 square block Fords, I think. Just a great... Anyway, we went to this tunnel back in 2020, and I don't know if you can see, the concrete tunnel's falling apart. They ended up having to stop using it because the concrete is just falling off the ceiling, and pieces were falling on cars and really just having a hard time. So the plan was they were going to fill the concrete tunnel with sand and forget it ever existed, no longer use it. This is a 400-foot long tunnel. 20 feet tall, 25 feet wide, and it has 7 full construction joints. Over it is anywhere from 18 to 40 feet of soil, and there isn't flashing over the construction joints. There's a geosynthetic fabric, but the concrete walls and ceiling, they're 18 inches thick. Any questions?
Wow. Thick walls.
Thick walls. So we were told, hey, we're going to fill this up with sand. We're going to forget about it. So whatever you want to do, go ahead and do it. So what we did is we treated the tunnel as if it was an experimental zone, where we took half of the tunnel, the pink half, and we just focused on the joints because that's where all the damage was located. We cleaned up the pink side, knocked and sounded it, and pressure washed it. We did the same thing on the left-hand side, the black side, but on the black side or left-hand side, we put different dosages and different types of Eddystone. Okay? So the total application was pressure washing it with a 3,000 to 3,500 PSI pressure washer. We also did knocking and sounding. We allowed it to get to a saturated surface dry condition. And then we applied the hydrogel technology in successive coats up to 125 square feet per gallon. Now, this could have been anywhere from $1.50 to $5.50 per square foot. Okay? Now, this is not how Eddystone is used all the time, but it is specific to the amount of damage that we had with this type of concrete. Questions?
Nope. This is great.
So,
what were the... Yeah, go ahead.
So we pressure washed it. We put on the Eddystone. We came back 4 months later, took pictures, and we also cored samples, 2 samples on either side of the joint. And then, of course, we did the side with and without the Eddystone. So in total, we were looking at 56 samples that were sent out to 3 different facilities to be tested. And what we found is wherever we used the Eddystone, we used ASTMC 1585. Wherever we used the Eddystone, the colloidal silica hydrogel, there was a reduction in not only primary absorption, but in secondary absorption. And we also, the numbers matter, but when we took pictures, we saw a difference in water that was being contained within the concrete and not doing anything but causing damage and corrosion to applying the Eddystone, and a change in what the concrete was doing. Now, what I think you were talking about is this was during the rainy season in Indiana. It was raining nonstop, and we had 18 to 44 feet of soil on top of this. So water was just dripping through, and this is that first image. What the Eddystone does is, a lot of people call this technology a waterproofer or a sealer, and it's not. I mean, this is colloidal silica. It creates pozzolanic reaction. It should not be mistaken for an epoxy, a silane, a methyl or an MMA, methyl methacrylate. I mean, it becomes one with the concrete, but it does imbibe more water. And what we saw, this is 18 hours after applying it, is that there was water dripping through all of the joints. But wherever we had sprayed the Eddystone, that water was being used to create more of that hydrogel. Now, please bear in mind, this was not a long-term phenomena. This was happening within the first 72 hours. Once the hydrogel got back to a saturated state, we had to go back and take care of the problem, which was there was water filtering through that joint and it was unregulated. And if we didn't do something about it, the concrete was just going to turn into crap. Does that make sense?
Mm-hmm. Mm-hmm.
Can I show you what we had done after that?
Yeah. Oh, yeah.
So we had come back about a year and a half later. It's starting to drip through the joints. And we have this sister product, this geostone that you mix into or inject into soils. And there was no way we were going 18 or 40 feet into the soil. That just wasn't going to happen. So what we did is we came back to that same joint that you were looking at, and we drilled 2 inches off the joint at 6-inch spacing from each other, kind of like a sewing pattern. And we drilled, when we were closest to the center of the joint, we drilled 12 inches into the soil. Then we hit the sidewall, it was 2 inches into the soil. And then what we did is we injected the geostone. Now, what that does is it creates not a flashing, but a grade for the water to travel away from the joint. And what you're seeing here is we came back a year later and there's no water coming through that joint anymore, and it's going around the concrete wall. Does that make sense?
Yeah, that's awesome. So it's interesting you mentioned that about the soils. So earlier when you were describing this technology, and then you showed us that sand in the to-go container, the very first thing I thought about was soil stabilization.
Right.
There's a lot of guys that are mixing cement and sand, or just dirt, and I mean it's expensive. I don't know if I don't know if this is cost comparable to having 5% of cement dropped on the ground and mixed in, or
no, nowhere near that. But you don't need the equipment. You don't need the PPE. You don't need to take your soil out and mix it up, wait a couple of days and bring it back.
Right.
I mean, this stuff is, if you want to inject it, if you just want to pull it on the ground and let it filter in, and it works based off of, for the soils, the salt in the soil. Yeah. And if the salt's not there, we just add salt.
Yeah, that's we have to do that with Actigel sometimes, not in concrete, but in other applications where if there's no surface charge, it's like, well, I guess we're going to add some charges. And it's like, well, well, how you do that? It's like, table salt, brother. We're gonna
Table salt.
add a little bit of salt.
And there's different types of salt that you can use to control strength and reactivity. So table salt is a general term. And when you say table salt, I say the Hofmeister series.
Mm-mm.
You guys know what the Hofmeister series is?
No. What is the Hofmeister series?
Salting out versus salting in of your hydrogel, right? When you look at ASR gel versus the gel we just talked about, right? Why isn't this doing the same thing that ASR gel is doing, right? Where we're using silica, we're using alkalis, and it's creating a gel. Isn't that a bad thing, right? And the answer is, well, it's the adult diaper. It depends.
Oh, that's terrible. That's a terrible joke.
Joey likes.
I don't even know if we're going to be able to leave that in. I don't think we're going to be able to leave that in.
Joey's laughing so hard he's frozen. So the difference being is the silica that turns the alkali juice into ASR gel is a tetrahedral form of silica. Right? That's what concerns us with and I'm dumbing it down a little bit. When we're working with the nanosilica, when I say it's amorphous, it's a meatball of silica that is rounded up amongst itself until it becomes this amorphous blob, right? And it's literally like a piece of spaghetti. Based on its molecular makeup, it will dissolve from that meatball differently, and it will recombine with alkalis differently than the silica that we get from chert or opal.
I thought the problem, maybe I'm missing, maybe I'm just dumb, and maybe we're talking past it, but I thought the problem with ASR, the gel that's forming in ASR, is the fact that it is forming around silica particles that are in situ, and you've now created an expansive product in this gel that has nowhere to go, and concrete's going to lose that battle every time. The gel wins.
And it's around the aggregate. It's at a very weak point in the concrete, your interfacial zone between the hydrated cement matrix and the aggregate body, where there's a little amount of paste. It's called the
and then this. And why I wasn't connecting. I did not make that connection, although we were using alkalis and silicas, and I didn't make connection because your drawing there, your depictions were very clear that you're filling voids that exist. So even if you have an expansive gel, it's in a void, so that you're and in fact it turns into a CSH product that bonds, and now you're adding strength. So I didn't make that, and I actually don't think our listeners will either. I think it's actually a very, very fascinating concept what you've done here, and so I'm glad you were able to share those slides and bring that up and actually show people this is out in the real world. It's out in the wild. It's doing things that we're not really thinking about, because I don't know any. You see, I shouldn't say anybody. You see a lot of academic papers that want to talk about healing concrete and self-healing concrete, but nobody's out there doing it, man. Right. And that drives me bananas. People want to talk about ECC or flexural this or geo that. Like, come on, man. Like, I want to see real stuff. So that's why I like having you on here.
So this was a project that we did, and bear in mind, we don't work with friendly engineers.
Oxymoron of the day.
Right, like none of them are nice.
No, that's not true. That's not true.
None of them. Name one engineer that's nice. One.
What I'm thinking is, like, the not nice people are usually the inspectors. Those are the guys that are usually not nice.
Rich Sachy's not nice. He's mean.
That's why we let him go on the. Hey, Rich Sachy. That's why we let him go on the Concrete Logic podcast. He's not allowed over here. I mean, that's just part. I'm joking.
And the first shot was taken. There it is.
No.
So
you were cluing us into him 4 years ago, and of course we did not call him for any reason at all. We had all these other guests, and then he shows up like 5 different times. He's the number one most viewed guest on the Concrete Logic podcast. He might be 2 of the top 5. So he's obviously well known, well liked.
Is number 1 right now. I'm number, I think, 18 out of 18. So I get a so that's the best part. Call Rich, email him. I can set up an email. He's easy and awesome to talk to, and he loves talking concrete. He's great.
Yeah, he was great on that podcast. And by the way, here's another plug, and Seth will have to pay us for this one too. If you haven't listened to the Concrete Logic podcast, it's absolutely great. It's different. It's a completely different format than this, and how he does his show. But there's value to having different voices.
Well, and then they also give T-shirts, and you guys don't. So
no, we do, but only to people we like. And then we have
Joey. Take that out. That's not nice.
I want
click.
Yeah, because we're gonna send you the numbers of all the guests that we sent care packages to, and if you didn't get it, I mean, what does that say? Maybe there's something you got to do better.
Oh, see, this is why you need to be an engineer, because you're not nice. You're mean. A plus B equals C.
It's actually surprising to me right now that you're telling me you never got the T-shirt or the koozie or the pin. You never got any of that stuff after you were on with us?
Koozie, I would have yelled at you for a koozie because I think koozies are the worst.
Well, that's your fault. Yeah. See this cold drink that was freezing my hand earlier? It wouldn't be if I had my Add 10 Gallons Concrete podcast koozie, but my daughter took it, and I don't know where it is.
Use a warm bottle of water instead.
A warm bottle of water? Yeah, I saw you drinking out of that giant glass bottle. My wife does that. I don't know. She's also, but you have a screw top lid. She has one of those lids that's like a cork, and you just press down the little metal snap on the end. I think it reminds her of the old country or something like that.
Well, this is not reusable. I stopped drinking alcohol and sodas, so this is how I treat myself every day.
Man, that's interesting you say that. I just saw a post on LinkedIn. Somebody else in our concrete world, they also stopped drinking alcohol, and I've never drank it. Joey's talked on this podcast before. He doesn't really drink anymore either. And my wife stopped really drinking. I think she's had 1 drink all year, and it's interesting how many people in our generation have just decided, I really don't think it's that good for you.
No, it's our conferences. I think it's from our conferences. And when I was growing up in the industry, a lot of our mentors did a lot of stupid things with booze. And it was normally me and somebody else who had to go schlep them into a cab. So, yeah, it just cured me. Like,
hangovers ain't worth it.
No. Those
you ever
hangovers,
tried to parent?
Oh, my gosh.
You ever tried to parent while you're hungover?
No, yes.
Yes, just shoot me directly into the sun. Yeah, it's terrible.
But take care of my kids first.
Yeah.
Okay. Before we start making fun of people and their drunken tactics, this job site.
Yeah, we're looking at it. Bridge deck. What you got?
So a lot of problems that they've been having in bridge decks all over the Western U.S. business unit is delamination from new concrete on old concrete decks. Jan Olick wrote a wonderful paper from Purdue back in 1999 that looked at the collection of salts between 2 different concretes, and that propagates that delamination from osmotic pressure. So ultimately what we were doing here is 20-year deck in Indiana requires hydrojetting of the deck no matter what the surface looks like. And then you come back with a 4 to 6 inch concrete overlay. The problem that they've been having is delamination of that overlay from the deck, even with the dimpling and the hydrojetting that they've been doing. Pressure washed it, got it to a saturated surface dry condition. We only used it not at 125 square feet per gallon, but we used it from 1,000 to 750 square feet per gallon. That came down to 35 to 50 cents per square feet. And the prep work was more around the realm of $5 per square foot. Now, we came back a couple months later and we did an echo rebound, and not my words, but this is the best concrete deck that they've had with the least amount of delaminations. And they do this point on either side where they put striations or really tines in the concrete. You can see the delamination point, all these red blotches. Normally, they would see that throughout the concrete. Mm. We also did concrete pull-off strength. Oops, right? You can see that, right?
Yeah. What test do you do? Did you make one up? I don't mean that negatively. Like I looked for like a real pull-off test to test bonding. What method do you know?
What is it? ASTM D4060? No.
Oh, is it in the D category? Is it one where you do like the 2-inch cores and you put a hook on each side and you try to?
No.
Is it a shear test? I can't remember.
No, it's a pull-off. So it's the same concept as the ASTM C1583, the surface tensile strength, but now you're doing coatings on concrete surfaces. So it's ASTM D. I'm afraid to look it up on my computer. Yeah,
it might. As much as we love Riverside, you start doing too many things in the browser. While those things going, it does get a little angry at us.
So it's not 4060 because that's abrasion. Pull off coating.
All right, 15. Don't make me pull out my standards.
4541.
1583.
1583 is surface tensile strength, but it's 4541.
All right. All right. Sorry, that was a legit question because we had a bunch of these types of tests that we tried to run back in the day, and we're always looking for the best way to do it. So
it's what you had said, doing the 2-inch, not the 2-inch core, and then you've got to go a certain depth into the slab below it. Where is it? So here's one of them. This is not the one that we did for this. This was an epoxy coating, but we still had to go, somewhere around 2 inches into the concrete to see what the bond strength between these two were.
Yep.
Okay.
Yep. And so we have you have some nice simple. I love simple charts. Thank you. When things get too complicated, like the chart before this, I know that one wasn't your fault, but golly, there's stuff the one before it with the sound stuff. This one's great.
This is not a chart, really. This is a picture of 2 lanes of traffic.
And so it's like you're looking at trying to figure out what in the world this thing's telling you. But you did a great job explaining it. So I love simple charts.
What we also did was, again, and it's not that he's not a nice person. Mike Nelson is a really nice dude, but he's just a mean engineer, right? Like, the final answer doesn't matter. I need to see the work, Belkowitz. Like, those types of engineers that we had in school or professors we had in school. So what he did was he wanted to see the echo rebound. He wanted to see the pull-off strength, but then he wanted to see the petrographic analysis at what's happening at the interfacial zone. And, it's pretty cool stuff that, with the reference, you're having the salt or calcite layer develop between the two, overlay and the concrete substrate, and over time that'll expand, and that'll cause that delamination between two rigid materials. And then where you're using the hydrogel, colloidal silica based, you don't have that hydrogel, or you don't have that calcite layer, and then you do have better interconnection between the overlay and the concrete substrate.
Man, what a cool picture that is side by side.
And we have more than this. So, there's another drop site that we did, which, if it's okay if I go on to the next one, and this one will be fast.
Yeah, no, it's great. Please.
So, a lot of issues going on with transportation concrete, pavements, bridge decks, overlays, is that we're losing the concrete surface within 10 days to 6 months of finishing the grooving. Now just let that sit for a second. 10 days to 6 months after the concrete has been grooved, when it was designed for at least 20 years, if not 30 years or more. So this is not old concrete. This is premature, failed concrete. First by the grooving, and then This is a topic for another discussion for folks who are smarter than me. What's going on with different types of cements and finishing and production techniques?
That's like, I mean, how many podcasts could you do on that subject right there? Jesus Christ.
Had nothing to do with it, but I tell you, the people who call you and threaten you when you start doing that need to find him.
Yeah, we're gonna have. For those who can't see, Dr. John's expression went from "I was having fun on this podcast" to "we're about to get to a really, really dark place on this subject." So we're gonna have to move. We gotta get back on. We gotta get back on healing concrete. Healing concrete, Dr. Belkowitz. Healing concrete.
Yeah, we better not do that subject. No, I was about to unleash the fury, and I just like, you're an adult. Calm down. So folks are losing their surfaces well before the design life, right? And this is a picture of it. You know, this is a concrete slab. I mean, it's a pavement. It's a deck, or not a pavement. It's a deck. It was grooved. Paint was put on. Mm-hmm. Less than 6 months later, the surface is falling apart. The paint is coming off. So the whole idea was, what can we do to extend the service life? The service life evaluation, the estimate, the pavement index, whatever you want to call it. And it ultimately was adding that same amount of topical technology at 50 cents to 25 cents a square foot, you know, after we got it to the saturated surface dry condition. And then what we did is abrasion resistance. And for my ASTM hounds, we did ASTM C 1083, which was the modified version of ASTM D 4060, which is the Tabor abrasion test. And what we found is anytime we applied the eddy or the colloidal silica hydrogel, we saw anywhere from 18 to 25% reduction in mass loss due to abrasion. And then when we did the petrographic analysis, what we saw is without the colloidal silica hydrogel, we had more aggregate shadows, more aggregate being torn out, more rounded aggregate that was losing its paste, really aggregate that wasn't contributing to abrasive wear, comparing to when we used the Eddystone, we had aggregate that was worn down, polished down, and a place layer that was indicative of good bonding between the interfacial zone at the aggregate surface.
These images are something else, man.
Thank you.
This is cool. Hey, Dr. Jon, thank you so much for, really educating us on what's new, what's interesting, what's actually working out in the real world. Not just, and we didn't even get to talk about our favorite white papers today. We're going to have you back on. Just so if you're not familiar with Dr. Jon's work, check him out. His LinkedIn is amazing. His YouTube channel is fascinating. But he also has something he's told us here on this show, which is he wants everybody to read one white paper a month. It doesn't even have to just be concrete or cement related, but we should all be reading. We should all be getting smarter. We were going to talk about our favorite one. Unfortunately, he had to pull it out of some secret tabernacle. I think he borrowed it from Indiana Jones. I'm not really sure where he got it from, but maybe Christ himself handed it in. He's showing it on screen. His Papers of the Lost Ark over there. And I just want to say thank you for coming on. Is there anything else that you wanted to share with the audience before we let you get back to your real job, get back to moving from New Jersey to Indiana?
Cannot wait to do that. A couple of things. We go through, or three things. We go through concrete papers and how to read them. Don't be embarrassed if you can't read it in one shot. It normally takes me, for a good paper, it takes me a month, 2 months to read the thing through and through. When it comes to repair techniques, you've got to look at it more if you were dealing with a child. When a kid gets a scrape, you're not just going to put a Band-Aid on, right? You're going to clean the wound. You're going to apply either, if you're a hippie, a Vaseline or some type of poultice, and then the bandage, or in my case, an antibiotic and then the bandage. So if you look at it like that, you'll start thinking about your repairs from more of a long-term approach. And I guess the last thing is for this next generation of concrete folk, we are inheriting a retiring infrastructure as well as meeting the exhausting demand of new infrastructure that is repairing a lot sooner than we had intended. Good luck, Godspeed, and if you need help, don't hesitate to ask any of us for help. Oh.
Amen to that. Almost every single person we've had on this show, by the way, has that same sentiment. Feel free to reach out. There is a community around this show. Dr. John, you'll certainly be getting your t-shirts. Joey, you sat there patiently, silently, having to endure Dr. John's dad jokes, having to endure my comments that were not nearly as smart as Dr. John's wise words. What do you have for the audience before we get out of here?
I've always been told that if you're talking, you're not learning. So I just learned a lot on the podcast
today. Oh, he's so cute. Oh, you're freaking adorable. I want to keep him.
He's expensive, boy. You can have him.
I'll take him. He's worth every penny.
You don't want me.
That's great, man. Hey, thanks again, Joey. Appreciate you putting this together. Dr. John, you're the best, man. Everybody, this is another episode of the 10 Gallons Concrete Podcast. Look out for us. We'll be coming to you in a couple of weeks with many, many more wonderful guests.
My whole life I just wanted someone who would notice me. My whole life I just wanted to be somebody to be. Yeah, I just wanna be great. Yeah, I just wanna be great. Yeah, I just wanna be great. Yeah, yeah, yeah.